The world is, in fact, wireless. Being tied to a desk anymore with a wire seems like a punishment. But is Wi Fi always the best solution to all of your problems? Well, if you're using anything more than a laptop and a tablet, I would bet that the answer is probably no. In this episode, we find out whether or not Wi Fi is always the best solution. Welcome to the Tech Field Day podcast, where we bring together a group of IT experts to discuss a single idea around key concepts in the enterprise IT industry. This podcast features a variety of perspectives from members of the Tech Field Day delegate community and is often recorded in association with one of our events. Tech Field Day is a part of the Futurum Group, and this podcast is also published on our sister company site, TechStrong TV. On this episode, which we're recording ahead of Mobility Field Day, we're going to be discussing an interesting topic related to Wi-Fi. But before we do that, I'd like to take a moment for our guests to introduce themselves, starting with Lee.
So I am a wireless network architect by trade. I'm also very interested in a whole bunch of other wireless stuff, both professionally and on the hobby side, as a ham radio guy, among other things. But looking forward to talking with everybody today.
Awesome. Troy?
Hi, everyone. My name is Troy Martin. I'm a wireless practitioner working in all areas of wireless beyond just Wi-Fi, but other wireless IoT and other more proprietary technologies. I'm looking forward to the discussion we're about to have today.
And lastly, Ron.
Thank you, Tom. Yes, Ron Westfall, Research Director here at the Futurum Group. And I always enjoy our conversations, especially around the upcoming Mobility Field Day 12 around the corner.
All right. Well, thank you all for joining us today. Let's jump into the premise for the episode. The world has changed significantly once we realized that we didn't need to be plugged into things anymore. I can remember a time when the only way to get your email was if you had an Ethernet cable plugged into your desktop. Now we live in a world of laptops, tablets, and phones that use wireless communications to receive all of that data. But there are some times when Wi Fi isn't the best solution. And we wanted to discuss some of those today. Now, I know that everyone out there is probably already firing up the comments about how Wi-Fi is the most amazing thing ever and I can't live my life without it. But a lot of people do. And a lot of people don't even turn on the Wi-Fi, especially if they work in an area where it's not feasible to use Wi-Fi or it just plain stinks. So I want to open this up to my fellow wireless friends here. Where are some situations where you see that Wi-Fi isn't the best solution?
So I was recently dealing with some researchers. I'm in higher ed, dealing with some researchers who are looking to instrument public housing, low end housing for energy efficiency and such. These researchers came at the topic from the perspective of Wi Fi. We want to put these Wi Fi based sensors in every housing unit, and Wi Fi is so cheap and easy, it ought to be a slam dunk. And then we started talking through it. How are you going to get on everybody's individual networks? The sensors that you're talking about all need an AC outlet plug-in. Just getting access to the spaces into people's homes. This is not going to be easy. The thing that you're trying to do with Wi-Fi. And then we talked about the benefits of LoRaWAN. Put one gateway somewhere, put sensors in the apartments. You're going to get one chance to be in these apartments. Get sensors in there with batteries that last years and don't need an AC outlet. And pretty soon it became pretty clear that this was a better application for what they were trying to do for their operational goals. Wi-Fi just didn't stand up in this discussion. So, there's one for LoRaWAN. There's certainly others, but I'll yield and see who else has got something.
Good point, Lee. I think it's not only about the consumer space, it's also about businesses and enterprises. And I think what we're seeing is more uptake of technologies such as private 5G, following on private LTE. That's certainly ongoing here in the U.S., but also globally. And I think what's important here is that I think you're going to see more, what can be characterized as private public implementations So it's not so much, Wi-Fi has to be ripped and replaced, but it needs an augmentation technology to really make wireless work optimally for an enterprise. So what we're seeing is more combinations of where private 5G is being implemented to take care of certainly the wide areas where Wi-Fi is really not applicable or in play at all, but also in challenging scenarios such as manufacturing facilities, mining environments, and so forth. And that's why we're seeing, I think, more interest in platforms that can provide unified visibility across both Wi-Fi and private wireless implementations, and that includes policies across both of them, administration, management, and so forth. So this is actually a very, I would say, competitive space. It's where I think the players that can address both effectively are going to be the most successful versus being, say, a Wi-Fi only type of play.
I find a lot of people that are familiar with just one wireless technology always want to find that as the solution for all of their problems. If their background is Wi-Fi and that's all they see, they try to solve that through some sort of Wi-Fi means, changing configuration, tuning their environment. Instead of looking at the bigger picture, what advantages or distinct characteristics of another wireless protocol better meet the design requirements that have been identified by the end customer and stakeholder. We've identified some common use scenarios, monitoring meters on the outside of homes or providing coverage across a large open pit mine. These are environments that classic Wi-Fi isn't really tuned or maybe even perhaps appropriately suited to. It's relatively smaller distance. It's very, very high bandwidth. But sometimes, if you're just monitoring sensor information, you don't need those. You don't need substantial amounts of data. You just need regular updates. Is a valve open or closed? Is a battery charging? Has a door open or closed? And you can provide that with other wireless technologies that cover extremely large distances, like upwards of 10 kilometers beyond with LoRaWAN, which has great advantages being an unlicensed protocol. Or you could jump into the licensed protocol space of 4 and 5G type technologies.
And I think pivoting off of the lower WAN aspect, it does bring, I think, more attention because, as we know, Cisco is discontinuing support of lower WAN. So this is opening up, I think, more discussion as to, okay, what are lower WAN's prospects? I think as a technology, as a protocol, they will continue to be solid despite Cisco's decision, which I think was also factored in by Cisco's overall corporate strategy. And I think what we're looking at is I'm getting a bit more interest in about what about Sigfox, which is, as we know, proprietary. What about waitlist, which is open, but it's sort of like some challenges with using TV white space spectrum to enable that. But I think it's an interesting time. It's really opening up how can we optimize the spectrum that's out there. It can certainly include established Wi-Fi, as many organizations are kicking the tires on Wi-Fi 7, as we know, but also maybe Wi-Fi, even when it's better suited than, say, a cellular technology. What are the alternatives out there? And I think Troy and Lee have really pointed to, what are some compelling options out there.
So I just wanted to touch on the Cisco discontinuing their LoRaWAN gateway support, and they're not recommending an alternative hardware solution to replace that component. They were a contributor to the LoRaWAN Alliance and developing these standards, but they certainly aren't a significant end all and be all of the LoRaWAN portfolio globally as a product set. There's many, many manufacturers that are out there making gateways. There's a plethora of sensors that are available and actuators that operate on LoRa. So the fact that Cisco's discontinued their product, it's interesting from a networking perspective, but I don't think it's a large piece of the LoRaWAN pie that's out there. There's also other technologies that we haven't mentioned yet, although it still has the same name, Wi-Fi, Wi-Fi Halo, that addresses a lot of the sweet spots in wireless communications. It provides sufficient bandwidth. So we're looking at 20 megs, upwards of 90 megs throughput on a single spatial stream, but it also hits the sweet spot in terms of distance. being marketed as a 1 kilometer technology, but they've just hit a distance record, pushing lower or Wi-Fi Halo rather up to 16 kilometers successfully to communicate. So it's that neat technology that leverages the Wi-Fi protocol stack, but delivers meaningful bandwidth for a lot of applications at a much larger distance than we've seen previously from classic Wi-Fi technologies.
Yeah, it's intriguing. I mean, there's also you know, narrowband IoT and Symphony Link, and so I think you're right. Cisco was one participant in the overall LoRaWAN ecosystem, and that's not going away. There are plenty of suppliers out there, and again, I think Cisco's decision making wasn't necessarily a technology only decision; it was also a business decision. But I think it's just stimulating, conversation about okay, what are alternatives? Because to your point, Cisco didn't recommend a replacement technology, and so this is, I think, kind of what we're seeing on, say, on the AI side. A lot of tire kicking and stimulative conversations around what else can be applied to solve many of these problems. Energy saving, but with long range and of course the latency and easy to upgrade capabilities all factored in.
I'll tell you one thing I'm dealing with that kind of ties in a few of these thoughts. Large public venue, um, you know, sports events, the Wi-Fi ticket scanners have perpetually been crushed by people coming in through the gates, and you can try every optimization in the world, and it's still very challenging. So, hoping for the advent of CBRS ticket scanners, because the one venue I'm talking about, I have in mind, it is CBRS equipped. Those scanners would be ideal to get those critical devices out of the mix of Wi-Fi. There's also a virtual VR component and esports and all of that, and the desire to put the Oculus style headsets on wireless, and it needs to be super high speed and low latency and all of that. Even with 6 gig, 6 gig is going to be polluted pretty quick. People are going to pop up their own home routers the way they do now in different venues, and it's hopeful that 6 gig makes everything a lot better, but it's not going to be a grand panacea. So in this one VR setting, we're going with a 60 gig link between the PC and the headset, and that was basically developed for these VR applications. So lots of things that you can do over Wi-Fi, maybe are doing over Wi-Fi now, but they're also either real world pain points or potential pain points. And it's just so nice to think about vacating that very popular spectrum that is Wi-Fi and looking at the alternatives, and there, all the other advantages, power savings, and all of that. Absolutely has merit and it's worth talking about. But just being in other spectrum is such a good feeling when you get there and see, hey, there's really nothing else here. This works great.
I've heard a lot of discussion around using other alternate technologies for very specific use cases. And it feels to me like one of the things that a lot of companies have said was, well, if Wi-Fi is the way that we go, then we have to build our devices to meet a certain kind of criteria. And in a lot of cases, what that means is, they have a higher power budget because Wi-Fi radios are a lot more power hungry compared to smaller devices. Like Troy alluded to, sometimes they don't need to send a ridiculous amount of data. They just need to send updates and things like that. Do you feel like the explosion of non-Wi-Fi wireless technologies is allowing vendors and manufacturers to create devices that fit in a better power budget or range budget, simply because, well, now that I know that I don't have to include a Wi-Fi radio in there or make sure that I have a Wi-Fi infrastructure, I can change the way that I build these things.
I think there's a lot of complementing technologies that that are fine tuned to meet the needs of different application requirements. And we're seeing this across a lot of the access points that are being released. Not only do they have Wi-Fi chipsets supporting both 2.4, 5, and 6 gigahertz, but as Lee was mentioning, those are some challenges using that unlicensed spectrum. These access points are also coming loaded with various IoT radios, whether they support Zigbee, Thread, Bluetooth. They also have USB adapters that you can connect even more IoT type technologies. You could add your LoRaWAN gateways, 802.15.4 radios, wireless HART, ISA 100.11a radios, and expand upon that. So we're already building an infrastructure and ecosystem that allows us to bring a lot of different wireless technologies all together and then use that as a staging point to expand and deploy support other devices connecting to our network as we need to across a common platform, which gives us one device that we can manage, but enable multiple radios to support different types of end devices with their specific requirements.
Yeah, to add to that, I think it's the flexibility. It certainly can be on a per device, or it can be on a per product basis. It's literally giving the organization, the customer, the options, so they don't feel like, okay, I'm shoehorned into only having to use a Wi-Fi implementation. Again, there's the Zigbee, the Bluetooth capabilities. What I think is where a lot of the innovation is ongoing across all these wireless technologies, and it came out, at 5G Americas, is that now we're seeing, spectrum optimization. There is a spectrum shortage issue that's ongoing, certainly in the U.S., North America, and there are, plans to see how can spectrum be better rationalized in terms of how it's distributed, potentially how it's re-auctioned and so forth, and that's going to be important. But in the meantime, how can more channels be packed in on a per unit basis, on a per chipset basis? How can the spectrum be used where it's not going to cause egregious trade-offs with latency and power envelopes and so forth. And so I think that's where we're going to see a lot of innovation already. Major operators are like, over the next 3 years, realistically, this is the only way we're going to be able to get more out of the existing spectrum, and that's squeezing more capabilities out of the spectrum that is available to us over the next 3 to 4 years.
And I think that identifies one of the big contrasts between Wi-Fi and a lot of other wireless technologies that are out there is because they're limited and being squeezed for so much spectrum. They have those finite boundaries where they're paying significant dollars for access to that medium. They are trying to be as efficient as possible and squeezing every last moment of airtime and increase the number of channels that they have available to them. If you compare and contrast that with Wi-Fi, it seems very much the opposite. We just released 1200 megahertz of spectrum to the Canada and US and other countries as well. But we're looking at jumping up to 320 megahertz wide channels. And we still have to deal with the inefficiencies of Wi-Fi, where there's huge gaps in time, where there's just delays in communication, right? We're waiting for devices to back off and compete with each other, wasting time that we could have been transmitting, could have been sending data, just due to the built-in inefficiencies of that protocol. So we have an incredibly inefficient protocol that just won rights to massive amounts of spectrum versus other wireless technologies that are incredibly resourceful with the precious spectrum that they have available to them.
It's funny you mentioned those 320 meg wide channels. Wi-Fi is also one of those things where the standard is written one way and promises all of this stuff, and then it can deliver a fraction of it, and the multi-user MIMO, 16 by 16 Wi-Fi devices. I mean, there's a laundry list of like pie in the sky things that we all either hoped for or we're still hoping for when we think about Wi-Fi 7, but it seems to be a perpetual falling short on the way the standard is written and all the things that are marketed and promised versus what's realized. The other technologies, at least so far that I've seen, they're more true to what's promised, and that's kind of refreshing. Low raw WAN, you get whatever it is, three or four potential data rates, and you're going to get what's promised. There's no weird pie in the sky over promising. Bluetooth, same way. It's like you're getting what you're getting, and Wi-Fi tends to be this very strange paradigm of sounds great, give it a year, let's see what happens. And I find it just, like I said, just, you know comforting, refreshing, whatever you want to call it, when the other wireless standards are devoid of that goofiness that wireless has. Again, going back to the 320 meg channels, are we going to see that practically in the real world? It would be nice, but I'm eternally skeptical about that kind of thing.
It's interesting that you bring all this up, Lee, because it sounds an awful lot like the networking industry years ago when we had competing standards like Token Ring and FIDI and a lot of other stuff that you've probably only ever read about in a textbook. Because in the immortal words of Bob Metcalf of 3Com, I don't know what the future of Ethernet or the future of networking is going to look like, but we're going to call it Ethernet. Ethernet didn't win because it was the best protocol. It didn't even win because it was the most technically adept. It won because it was cheap and it was ubiquitous. Everybody had it and everybody supported it. And so everybody just kind of agreed to build around it. And I would argue that in today's world, we're still dealing with the fallout of having to work around some of the limitations of Ethernet. Are we reaching a point where we're going to fracture into multiple different kinds of protocols that are trying to solve the challenges of Wi-Fi without necessarily cleaning up the standard? It's like, oh well, yeah, we could try to implement this in Wi-Fi if we really wanted to, but it's probably just better to go over here and use, Wi-Fi Plus or whatever we're going to call that protocol because it's just faster. Now, it's only going to work on your device and it's not going to interoperate with anything else, which is kind of one of the things that makes Wi-Fi kind of so important in the industry. Are we going to get to a point where we're basically dealing with the token ring and the ArcNet and the FIDI of Wi-Fi?
Yeah, it's a great, I would say, philosophical question in some ways, where we had, what could be called, the religious wars of, the late 90s, early 2000s. And I think what is distinct here is that Wi-Fi is fundamentally a connectivity technology. Certainly, it relies on Ethernet, links to fully succeed where it's being applied for local connectivity. But I think what we're going to see is that the Wi-Fi ecosystem is so extensive that it's not going to extensively be garnished by competing technologies. I think it's going back to the fundamental point of Wi-Fi and what can Wi-Fi uh, do, but how can it be augmented to meet the business objectives of the business or the fundamental connectivity needs of the consumer. And again, it's about that flexibility. I think Wi-Fi, even with its limitations, will continue to be supported on a broad basis, and things like Wi-Fi 7 can help address some of the previous limitations. And I think that's how it's going to play out. It's not going to be okay. Ethernet eats token ring. It's going to be okay. Wi-Fi. How can it be best optimized where it's applicable? But how can it be best complemented by these alternative technologies?
I do think too, to your point, Tom, it's almost like a 180 on the, in my mind, the way you asked the question. It used to be an arms race for speeds and feeds and what wireless or what wired technology is going to win out and dominate. I mean, that's kind of what it felt like. Was the market was self-sorting, and then Ethernet eventually emerged the victor. At least in my mind, that's how it felt. When I was a networking child, and now today it's almost like we're not looking to get to one dominant wireless technology, but we're kind of all more enlightened and open-minded to finding the best technology for the individual scenario, and that allows for all of these things to come out, and just the overall culture of being wireless minded. It's like for a while wireless meant Wi-Fi to most people, and now, at least I think for us as technologists, wireless means just that, without wires. And now let's talk about the specific scenario and what's the best wireless fit for it. So I think maybe maybe there's more critical thought going on with wireless, and more adaptability to the individual scenario. And it's not just it has to be one technology to rule them all, like maybe it was when Ethernet kind of arose as the ringmaster. But like I say, it to me it feels different, if that makes any sense.
Yeah, I agree with the sentiments that have been shared as well. I think it's much less of a competition to find that dominant wireless technology, but enabling a scenario where we can deploy complementary solutions in parallel, operating to meet the needs of different applications. Now, tying it back across one kind of backhaul type system that's easy to manage under one one single pane of glass, that type of scenario, I think, is more desirable. But fighting for one technology over the other, or trying to convince decision makers that we have to choose one versus the other, I think we very much need to approach this as positioning complementary technologies and enabling multiple wireless backhaul or access technologies to deliver on the solutions that customers and businesses are looking for.
I guess we've answered the premise in the positive. Wi-Fi isn't always the best solution, but it matters more that you need to understand what your solution needs to look like, as opposed to just going out there and throwing something at the wall to see what sticks. Because every one of the competitors to Wi-Fi that we've discussed so far have a niche. Maybe it's distance, maybe it's being more optimized for sensors or things like that. If you're just expecting to drop something down and it's going to work mostly like Wi-Fi, but be a little bit cheaper or reach a little bit further, you may find yourself challenged. And that's why it's so important to be able to do the research on all of these things. And one of the places that you can learn about technologies like this is during Mobility Field Day, which will be happening November 20th in Silicon Valley. We have some great presenters, so make sure you head over to techfieldday.com and check out the schedule for that. We also want to thank you very much for listening to this episode of the Tech Field Day podcast. If you enjoyed this discussion, please subscribe to our YouTube channel and subscribe in your favorite podcast application. That way you don't miss an episode. You can also give us a rating and a review, which really helps us whenever we're trying to reach new audiences about things related to Wi-Fi or pretty much any technology. This podcast was brought to you by Tech Field Day, the home of IT experts from across the enterprise, which is a part of the Futurum Group. If you want to find out more information about our upcoming events, including those in 2025, make sure you go to techfieldday.com. And if you want to listen to the latest episode of this podcast, you can always find it at techfieldday.com/podcast. You can also check us out on TechStrong TV. Thank you very much for listening, and we'll be back with another great episode next week.